Friends, hello. This is your guide to the mysteries of military history, and today we have a topic on our plate that makes my hair stand on end the moment you start digging deep. This isn't just a story about tanks. This is a grand detective story, worthy of Agatha Christie, mixed with German perfectionism, wartime paranoia, and industrial-scale production. We are talking about Zimmerit. If you've never heard this word before, that's fine. You've definitely seen it in photos of German tigers or panthers with that wild, pockmarked surface that looks like the tank was plastered with frozen dough and then combed through. That's it. So get ready. Right now, we are going to break down how the Germans, who were famous for their engineering genius, managed to create a product that was 100% effective against an enemy that didn't exist. They won a battle against a phantom, wasted thousands of tons of resources on it, and ended up outsmarting themselves. This is a brilliant story of how fear and excessive self-confidence can play a nasty trick, even on the best minds in Europe. But before we dive into this abyss, let's agree right now. If you're interested in digging into such historical paradoxes, if you want to understand not just what happened, but why it was stupid or brilliant, be sure to subscribe to the channel, because the most interesting things are never on the surface, but hidden in layers like this Zimmerit. Let's go. I always thought that the scariest enemy for a soldier isn't the opponent, but time and distance. In 1943, a German tanker sitting in his Panther was afraid not so much of Russian anti-tank artillery, but of an infantryman with a magnetic mine. And this fear was justified. The magnetic hollow charge mine, officially called the Haftholladung 3, and nicknamed in the troops the Panzerknacker, the Nutcracker, or tank burglar, was a real nightmare. Imagine the situation. You're sitting in a multi-ton machine of death. You have the most powerful armor that even a T-34 can't penetrate head-on. But a figure jumps out of a trench and literally sticks a 3-kilogram contraption to your side using 3 strong magnets. It has a 4.5-second delay, and in that time it penetrates 140 millimeters of steel right through any Wehrmacht tank. This was contact weaponry, personal, almost suicidal, but it worked. The Germans produced 554,000 of these nuts from October 42 to May 44. And here's where logic kicks in. The Germans look at this weapon and think, my God, what an effective piece of filth. If the Russians or Americans had something like this, we'd lose all our tanks in a week. And they make a decision, create protection. Notice this is a rational grain of thought. But then the cognitive shift begins. Instead of asking, does the enemy even have such mines? They ask, how do we protect ourselves from what the enemy, logically, must copy? The company Chemische Werke Zimmer & Co. wins the competition and creates the paste we know as Zimmerit. The composition is a story in itself. Barium sulfate, zinc sulfate, ochre, sawdust, and a binding agent. And that binding agent was polyvinyl acetate. Yes, that's right, that 25% of the composition is just regular wood glue, the PVA we used in school for crafts. Mix glue with sawdust, add barium for weight, get a paste, spread it on the tank, run a comb through it for looks, and set it on fire with a blowtorch to dry it. Just think about the technology. Coating a tiger meant 200 kilograms of paste. It smelled of acetone so strongly that the factory workers' eyes probably watered. First layer, 5 millimeters. Wait 24 hours. Second layer, the comb pattern. Go at it with a blowtorch, burn off the solvent. No blowtorch? Dry it for 8 days. In the middle of a war, when every tank counts, they spend 8 days gluing sawdust to armor. And this was considered a normal engineering solution. I often hear from reenactors and modelers, oh, what a beautiful pattern. So aesthetic. Yes, the aesthetics were there, but that wasn't the goal. The goal was distance. Pure physics. The force of a magnet decreases proportionally to the square of the distance. You spread 6 to 10 millimeters of dielectric, and the magnetic mine that's supposed to stick like glue starts to wobble. Its holding capacity drops, could fall off over a bump. It might not even stick properly in the first place. And here's where the most interesting part begins. A debate that hasn't subsided for 80 years. Technically, from a chemical and physical standpoint, Zimmerit worked, created a gap. That's a fact. But strategically and tactically, it was a colossal failure. Why? Because the Red Army, the Americans, and the British simply did not have analogs to the Haftaladung in service at all. One-off sabotage magnetic charges like the British Clam weren't even in the same league. The Clam had a power of 200 grams of TNT, enough to blow up a car, not penetrate a heavy tank. The Americans and British relied on bazookas and Piats, the Russians on anti-tank rifles and artillery. So the Germans found themselves in a paradoxical situation. They have a unique coating that protects against a unique mine that the enemy doesn't possess. It's like buying reinforced doors with protection against lockpicking by a specific thief who is the only one in the world using that technique. And that thief is in jail working for you. And here my question is this stupidity or paranoia? Historians often say, they were afraid the Allies would copy the mine. Okay, let's say that's true. But let's look at the timeline. Zimmerit is introduced en masse in September-October 1943. The order to cease production of the Haftaladung mine comes in May 1944. The paste itself stops being applied in September 1944. So, for a whole year they carried this sawdust around, which, by the way, has a rather unpleasant property. It burns. Well, not the hardened glue itself, but the benzene vapors and solvents if the paste hasn't fully dried. A rumor starts at the front. A shell hit ignites the Zimmerit, and the tank burns alive with its crew. Guderian's order from September 7, 1944. To simplify production, the protective coating is no longer to be applied. Popularly, it said it was due to fire hazard, but official tests refuted this. So why then? Because the Inspector General of Panzer Troops simply realized, we are wasting time, money, and resources fighting an enemy that doesn't have this weapon. The absurdity of the situation became obvious, even to the most conservative minds. Let me give you a quote I love. A historian on a forum very accurately paraphrased the thoughts of the German command. The Inspector General realized that spending time and money applying over 100 kilograms of flammable paste to combat a non-existent enemy weapon was a bad idea. It is hereby ordered to immediately cease this senseless and wasteful practice. But the funniest part is that in the Zimmerit story, the Germans aren't alone in their folly. They certainly outsmarted themselves, but at least they created an industrial product. Their opponents, who didn't have these mines, acted even more interestingly. The Red Army, capturing captured German mines, panics and starts looking for ways to protect themselves. The instruction from the Belarusian front, dated September 29, 1943, is a masterpiece of soldierly ingenuity. It says in plain text, "Our tanks are burning, the Germans are sticking their magnets on our sides. Protection. Apply clay. Yes, ordinary clay. A layer of 8 to 10 millimeters. Freeze it, paint it white, and go into battle." It was claimed this reliably protected the tank. The mine either falls off during movement or explodes without sticking, causing no harm. The Finns went further. The Germans, apparently, shared their secret materials with them, and a Finnish manual suggests coating tanks with cement mixed with fine sand, 3 to 5 millimeters. And it worked. The Americans in the Pacific, facing Japanese magnetic mines, the Japanese were indeed the other user of such weapons alongside Germany, sheathed their Shermans in wooden planks and tarpaulin, just took boards and nailed them to the armor. The effect, the mines slid off. The British actually tried to copy German Zimmerit and failed. They simply didn't have enough polyvinyl acetate PVA glue.
Imagine.
The full power of the British Empire, control of the seas, colonies, resources of India and Africa, and they couldn't find enough glue sticks in sufficient quantity to replicate the German technology. They sent captured Zimmerit from a German factory to Australia for protection against the Japanese, but what came of it, history doesn't record. And this brings us to the meatiest part of our investigation, the economic aspect. War isn't just about shooting, it's about assembly lines, logistics, machine tools, and man-hours. Let's calculate the losses to German industry from this venture. Coating a Tiger, I required 200 kilograms of paste. A Panther, slightly less, a Panzer IV, around 100 kilograms. How many vehicles got the coating? From autumn 1943 to September 1944, almost all medium and heavy tanks, including Jag Tigers and King Tigers, let's say around 4,000 to 5,000 vehicles. Multiply by an average of 150 kilograms. You get nearly 1,000 tons of paste, 1,000 tons of barium, zinc, sawdust, and critically scarce glue. But more expensive than the material was the time. 8 days of natural drying is a production standstill. While Allied bombs were falling on Krupp and Henschel factories, while every Tiger was needed yesterday on the Eastern Front, tanks sat in workshops waiting for sawdust to dry. The Germans tried to speed up the process with blowtorches. This led to fires right on the production line. Benzene is volatile and flammable. Compare this to what came later. 9 million Panzerfausts and Faustpatrons versus 550,000 magnetic mines. 43 million Panzerschreck anti-tank rockets. The Germans realized the future lay in disposable rocket launchers, which were safer. You fire from 30 to 50 meters away, not crawling under the tracks with a magnet. And the entire multi-million-mark Zimmerit program just became archival dust. You know, this story reminds me of the modern IT industry. A giant corporation fears competitors will release a super gadget and pours billions into developing an iPhone killer, only to find out the competition went in a completely different direction and is making AI neural networks. The Germans made a magnetic mine killer for a war where the enemy didn't have magnetic mines. They were so sure the enemy would follow their path that they didn't even check their intelligence reports. And intelligence, by the way, was working terribly. If the Abwehr had reported in 1943 that there was no serial production of magnetic-shaped charges in the USA or USSR, millions of Reichsmarks could have been spent on fuel for aircraft. But let me play devil's advocate now. Was there any use for Zimmerit besides the hypothetical? Turns out there was, and it was discovered by accident. The British and Soviet specialists, during tests, discovered an amazing thing. This layer of sawdust and glue acted as a thermos. When a tank was hit with a flamethrower, the internal temperature of an uncoated vehicle would spike so high that the ammunition would start detonating by itself. The crew either burned or exploded. But if the tank was coated with Zimmerit, it held the heat outside. The temperature inside remained tolerable.
Plus camouflage.
The ridged surface breaks up the silhouette excellently. Paint adheres unevenly. Sun glints are scattered. The tank visually blends into the background. The British, in their 1945 experiments, wrote directly, "We are skeptical of the ridging as a method of mine protection, but the masking effect is excellent." So, the Germans could have marketed Zimmerit as an innovative thermal insulation and camouflage coating, and that would have been honest. But they were fixated on the magnetic aspect. And because of that, their brilliant development went down in history as a curiosity. Now, let's look at the bigger picture. World War II was a time of frantic technological leaps. The Germans invented guided missiles, the first operational jet fighters, the V-weapons. But Zimmerit is the flip side of this progress. It's an example of a complex technical solution looking for a problem that didn't exist. I often see comments, "Well, they were just over-insuring themselves. No big deal." No, friends, this isn't over-insurance. It's a symptom of a disease. By 1943, Germany had already lost the initiative. They had started to fear. They had started to defend. And this defense took ugly forms. Instead of building more simple, reliable tanks like the T-34, they hung sawdust shells on their Panthers, complicated the design, and wasted resources on secondary matters. And here's the end of this story. September 9th, 1944. Zimmerit disappears. The King Tigers rolling out of factories in October-November don't have it. Smooth metal, paint on metal, no kouming. Why did they abandon so easily what they had implemented with such difficulty? Because deep down, every German engineer understood. This was a simulation of vigorous activity. We had to counter the enemy with something. We did something. We're good guys. Now that's it, let's work faster. The magnetic mine was already obsolete. It was replaced by shaped charge grenades, against which Zimmerit offered no protection. I want you to feel this moment. Imagine you're the director of the Mann or Henschel plant. You receive the order, "Stop, no more paste." What do? Most likely, you sigh with relief, because hundreds of workers who were sitting with spatulas and combs are freed up. Drying shops are vacated. The risk of setting a tank on fire with a blowtorch disappears. The production cycle is reduced by a week. It's a victory for common sense over engineering paranoia. But we can't close the topic without answering the main question that haunts all tank enthusiasts. Did it actually work? If you take ideal Zimmerit, applied according to specifications, 8 millimeters thick, and a German mine, will it stick or not? There are dozens of videos and photos where modern reenactors attach powerful neodymium magnets to museum panthers with surviving coating. The magnet sticks. It sticks, damn it, and immediately the cries, "Fake!" Zimmerit was useless, but let's use logic. Firstly, museum Zimmerit is an 80-year-old desiccated substance. Its magnetic properties and thickness aren't what they used to be. Secondly, there are British reports from 1945, Soviet reports from 1947. They state, the coating reduces the holding capacity of magnets. Not completely eliminates, but reduces. That's enough. The mine needs to hold firmly for the shaped charge jet to form at the correct angle. If the mine wobbles or falls off during movement, consider the crew saved. Thirdly, look at pictures of the Germans applying Zimmerit themselves. They don't smear it everywhere. They coat the turret, sides, front, but they don't coat the bottom, even though the Soviet clay manual prescribed coating the bottom. Why? So a sapper couldn't get under the tank. The Germans don't coat the engine deck roof. They don't coat toolboxes. They don't coat tracks. This shows they clearly understood. Protect the zones accessible to infantry. No one is going to climb onto a hot engine to stick a mine. This indicates a systematic approach. And yet, I maintain my opinion. Zimmerit was the most dubious know-how. Why? Because a good engineering solution isn't one that works brilliantly in a vacuum. It's one that works in context. The context of World War II was multi-million-man armies, a meat grinder, production pushed to the limit. And in this context, wasting resources on protection against a threat that only materialized in the heads of generals was an unforgivable luxury. Here's a comparison from another theater of war. The British and Germans at sea. Magnetic mines were the scourge of the Royal Navy in 1939 to 1940. The Germans laid them off the English coast, and the British lost ships by the dozen. How did they solve the problem? They invented degaussing, neutralizing the ship's magnetic field by wrapping a current-carrying cable around the hull. Simple, elegant, doesn't require smearing clay or sawdust on the side of a battleship. That's genius. The Germans, facing the same problem, their ships were also sunk by Allied magnetic mines. Used complex systems like Sparebrecher explosive sweepers with powerful electromagnets. See the difference? One side looks for a simple, scalable solution. The other chooses the path of complexity. And so we return to our tanks. I want you to imagine an alternate history. The Germans don't invent Zimmerit. They look at their Haftholladung mine and think, the Russians are smart guys. If they want to copy the mine, they'll copy it. And defense against it should be tactical, not pasty. What do? They train infantry not to let the enemy near the tanks. They install anti-shaped charge skirts on tanks. Yes, they did this, but later and not everywhere. They ramp up Panzerfaust production earlier. And lo and behold, resources aren't wasted, tanks are produced faster, they still lose the war, but not because of sawdust. But history doesn't deal in subjunctives. Zimmerit existed, it's in museums, and it continues to stir minds. Why does this topic grip us so much now, 80 years later? Because it's a perfect metaphor. Look around. How many modern companies release products that nobody needs because they're afraid competitors will release them first? How many startups have burned out trying to defend against a hypothetical bubble? The German tank engineers are us in the worlds of business, politics, and even personal relationships. We often prepare to fight the last war. We defend ourselves against enemies that are no longer there or who never intended to attack. Zimmerit is a monument to humanity's capacity for forecasting errors. It's a beautiful, expensive, technologically advanced mistake. And I feel a strange respect for the engineers at Zimmer and Company. They did their job well. Their paste is still holding onto the Jag Tigers at Bovington and Kubinka. It didn't fall off, it didn't crumble to dust. It lay there for decades and became part of history. If they knew their product would be studied, photographed in macro, argued over regarding the comb pattern, they'd probably be proud. But if they knew their product didn't save a single tank from an enemy mine because the enemy preferred to fire a phosphatron into the side rather than run with a magnet under machine gun fire, they'd probably be disappointed. We've done a huge amount of work today. We've traveled from the chemistry lab to the battlefields, from the economy of the Third Reich to the tactics of the Belarusian front. And now I want to hear from you. What do you think? Can Zimmerit be called stupid? Or was it a wise move that simply wasn't needed? Are there analogs today in modern military technology of such defenses against a non-existent enemy? Write to me in the comments. I'm incredibly interested in your opinion. I recently spoke with a subscriber who works in the defense industry, and he said a phrase, "Every second prototype we have is Zimmerit, just a waste of money, and it's a pity." Let's discuss this openly. And finally, if you enjoyed this deep dive, if you love history not from textbooks, but with a human face with analysis of mistakes and unexpected conclusions, subscribe to the channel. Ahead of us are dozens of similar stories. We'll break down why the Americans thought the Sherman was a bad tank even though it won the war. We'll talk about how the Japanese built aircraft carriers out of concrete. We'll dig into why the Red Army loved the Sorokopayaka 45mm gun and hated 45mm subcaliber shells. This is all our past, which is actually the key to understanding the present. Hit the like button if you want me to make a separate video about magnetic mines at sea. It's a wild story with degaussing that still makes engineers' eyes pop out. Thank you all who read this far. You are true history fans. Take care of yourselves and remember, even the most terrible mistakes of great minds are just experience. And this experience is packaged in sawdust and PVA glue, smeared on a tiger. Paradoxically, that's what genius looks like when it fires a blank.